AI broke the internet again, and this week has been absolutely insane. Anthropic just released a new AI model that helped Stripe complete a codebase migration on a 50 million line codebase in a single day, a project that would have normally taken an engineering team over 2 months. Google just turned real-time language translation into something that feels straight out of science fiction. Microsoft built a new world model that's over 10 times faster than the previous state-of-the-art while using 55 times less memory. Researchers trained a robot using just 30 minutes of first-person human video and achieved a 92.5% success rate without collecting any robot demonstrations. Meta researchers found a way to completely change the camera angle of a video while keeping the scene physically consistent. xAI launched a new image-to-video model that can animate a single image into a cinematic sequence. And we even have a new open-source model trained on decentralized compute that could point toward a completely different future for AI development. So let's jump right in. First up, Anthropic just launched Claude Fable 5 and Claude Mythos 5, and this one deserves real attention because the capability claims are backed by specific external evidence. Let me give you the concrete numbers first. On Cognition's Frontier Code benchmark, which tests whether models can pass difficult coding tasks while meeting high-quality production codebase standards, Fable 5 scores highest among all frontier models. Stripe ran their own test. On a 50 million line Ruby codebase, Fable 5 completed a full codebase-wide migration in a single day that would have taken an entire team over 2 months by hand. Cursor says it's opened up a class of long-horizon problems that were out of reach for earlier models. IMC ran trading analysis evaluations, and Fable 5 aced them nearly across the board. Factual lookup, conceptual reasoning, root cause analysis, and expected value analysis. On vision, Fable 5 can rebuild a web app's source code from screenshots alone. It beat Pokemon Fire Red with a minimal vision-only harness, while previous Claude models needed a complex helper harness with additional tools just to make progress. On Hebbia's finance benchmark for senior-level reasoning, it scores highest of any model. The memory and long context story is interesting. In their Slay the Spire test, giving Fable 5 access to persistent file-based memory improved its performance 3 times more than the same treatment improved Opus 4.8. Fable also reached the game's final act 3 times more often. On drug design, this is from the Mythos 5 side. Internal protein design experts accelerated aspects of the drug design process by around 10 times. Out of 14 protein targets, 9 yielded strong candidates. The model chooses binding sites, runs protein design tools, and recovers from failures with no human assistance. One Mythos-generated hypothesis about an E. coli protein mechanism was independently corroborated in a bioRxiv preprint from a separate lab. Now here's what's different about this launch structurally. Fable 5 is the consumer-safe version. Some queries on sensitive topics, primarily cybersecurity, route to Opus 4.8 instead, which Anthropic says happens in less than 5% of sessions on average. Mythos 5 is the same underlying model, but with those safeguards lifted, available through Project Glasswing to a small group of vetted cyber defenders and infrastructure providers. Pricing is $10 per million input tokens and $50 per million output, less than half the price of Claude Mythos Preview. If you're interested in reading further, I'll link to the full announcement page in the description below. Also this week, xAI dropped Grok Imagine 1.5, their latest image-to-video model, live on the xAI API. And the pitch is simple. Give it a single still image and a text prompt describing the motion, and it animates the scene, camera moves, atmosphere, physics, while staying faithful to your source image. Output is up to 720p. The key capability they're highlighting is camera direction through natural language. So you're not adjusting sliders or specifying keyframes. You describe the camera move in plain English, like slow cinematic push-in as embers drift across the battlefield and the helmet's crest stirs in the wind. The model holds the lighting and detail of the input frame, so the generated clip continues the original image rather than reinterpreting it. They're also positioning it for sequence work. You stage each frame, animate it, and chain shots together into longer scenes that maintain a consistent look across a full project. The API is live now. If you're interested in reading further, I'll link to the announcement page in the description below. Also this week, Nex N2 Pro is out of SII, which is the Shanghai Institute of Intelligence under the Chinese Academy of Sciences. And the benchmark table here is legitimately interesting. So N2 Pro is built on a Qwen 3.5 base, a 397 billion parameter MOE model with 17 billion active parameters. The tagline on their page is "Thinking, built for action," which is their way of saying this isn't just a reasoning model. It's unified thinking designed specifically for agentic tasks, search, coding, tool calling, and long-horizon, multi-step workflows. The design principle is what they call adaptive thinking. Rather than forcing the chain of thought on or off, the model decides autonomously whether to engage thinking mode based on task complexity. According to their internal tests, adaptive thinking maintains task completion rates versus always-on COT while saving roughly 20% in token cost. It also shows task-aware reasoning profiles. In search tasks, it front-loads strategy decomposition. In SWE tasks, it concentrates reasoning at bug localization and fix verification. In long-horizon agentic tasks, reasoning peaks at the result integration phase. Now let's look at the benchmark numbers. On SWE Bench Verified, the standard software engineering benchmark, N2 Pro scores 80.8 compared to GPT-5.5 at 82.9, Opus 4.7 at 87.6, Minimax M3 at 80.5, DeepSeek V4 Pro at 80.6, and Kimi K2.6 at 80.2. So it's right in the competitive cluster. On graduate level scientific reasoning, N2 Pro hits 90.7, GPT 5.5 is 93.6, Opus 4.7 is 94.2, Kimi K2.6 is 90.5. Competitive. The more interesting one is Terminal Bench 2.1, which tests real long-running terminal tasks on 8 CPU/16 gigabytes RAM with a 4-hour timeout. N2 Pro scores 75.3, while Opus 4.7 is 69.7, GLM 5.1 is 58.7, and Minimax M3 is 66.0. N2 Pro beats Opus 4.7 by about 8 points on this one. That's pretty notable, given Opus 4.7 is a frontier model. On BrowseComp, web browsing agent benchmark, N2 Pro hits 83.7, GPT 5.5 at 84.4, Kimi K2.6 at 83.2, Opus 4.7 at 79.8. Again, competitive at the top. The awesome thing is both Pro and Mini are fully open weight on Hugging Face. N2 Mini is a 35 BA3B variant for faster, cheaper deployment. Available on OpenRouter and Silicon Flow right now. If you're interested in reading further, I'll link to the model page in the description below. Also this week, Quasar is a pretty interesting one because of how it's being trained, not just what it is. Silks AI is a frontier research lab built around one thesis. Use linear attention instead of standard softmax attention, and train entirely on BitTensor's decentralized compute network. Quasar 3BA1B Preview is their first public release, a 3 billion parameter MOE with 1 billion active parameters. The linear attention angle matters for the following reason. Standard transformers scale quadratically with sequence length. The more tokens you add, the more expensive attention gets. Linear attention scales linearly, which means you can handle millions of tokens at a fraction of the compute. The goal for Quasar is to become a genuinely capable long context model without the hardware requirements that currently make long context frontier models expensive. The BitTensor training angle is equally interesting. BitTensor is a decentralized compute network where miners compete to produce the best model checkpoints. SILX runs their training on Subnet 24. The idea is to make frontier-class model training accessible without needing a centralized GPU cluster. This is still a preview release. They're actively training, and the architecture is evolving. But the direction they're pointing is clear. Open weight, long context, trained on decentralized infrastructure. The weights are on Hugging Face under Apache 2.0. If you're interested in reading further, I'll link to the SILX AI page and the model in the description below. Also this week, LeVar from Meta Reality Labs is a really interesting CVPR 2026 paper that solves a problem video generation models have been struggling with. The problem? Take an existing video and re-render it from a completely different camera angle. Maybe you want to orbit around a scene that was captured from a fixed tripod, or view a conversation from the other side of the table, or add a cinematic crane shot to footage that was handheld. The three existing approaches all fail in specific ways. Non-3D methods, like Recam Master, get high visual quality but no geometric awareness. Methods that condition on 4D point clouds, like Gen 3C, get geometric consistency but lose quality because point cloud rendering is sensitive to depth estimation errors. And Trajectory Crafter distorts bodies and objects when geometry is ambiguous. LeVar takes a different approach entirely. Instead of conditioning on a rendered point cloud, it conditions on the implicit geometric knowledge inside a pre-trained large 4D reconstruction model. The LRM has already learned how 3D scenes work, so you extract that internal understanding from latent space and use it to guide the video diffusion model directly, without rendering an intermediate point cloud. The quantitative results confirm this. LeVar outperforms all three baselines on both consistency and camera trajectory accuracy. CVPR 2026 accepted. Paper and code links are on the project page. If you're interested in reading further, I'll link to the page in the description below. Also this week, the VLLM team just launched VLLM Omni. And if you run your own model serving infrastructure, this is worth paying attention to. VLLM is the most widely used open source LLM serving framework. It's what most self-hosted deployments run for efficient batching, quantization support, and high-throughput inference. But until now, it only handled text models. VLLM Omni extends the framework to omnimodal models, meaning models that take in audio, video, and images alongside text. So if you're running something like Gemma 412B, Qwen 2.5 Omni, or any of the multimodal models we've been covering, you can now serve them through the same VLLM infrastructure you already have, with all the batching optimizations, continuous batching, memory management, and KV cache sharing that makes VLLM fast. The GitHub repo is live and open. If you're interested in reading further, I'll link to the repo in the description below. Also this week, HumanEgo out of the University of Maryland is a robotics paper that challenges one of the most expensive assumptions in the field. The assumption? To train a robot to do a task, you need robot data. Teleoperation recordings, robot arm trajectories, thousands of demonstrations collected on real hardware in a real lab. That's expensive, slow, and not scalable to new tasks. HumanEgo asks, what if you just wore a pair of glasses and showed the robot what to do yourself? Here's how it works. A human demonstrator puts on Meta Aria glasses and performs a task. The Aria glasses provide 6 DOF SLAM tracking, calibrated 3D hand pose estimation, and synchronized egocentric video. Each demonstration takes only seconds to record. The key architectural innovation is interaction-centric tokens. Rather than feeding the raw video into the policy, The system lifts the hand-object interaction into an entity-level spatial representation. This bridges the embodiment gap. What matters is the spatial relationship between hand and object, not whether the hand is a human hand or a robot gripper. The policy then trains with dense auxiliary objectives: object motion tracking, hand pose, and contact prediction, each one amplifying the learning signal from every trajectory. The results? 30 minutes of human egocentric video per task, 92.5% average success rate across 4 real-world tasks. With just 15 minutes of data, 75% success rate. They then compared this to matched time robot teleoperation. Same amount of time spent collecting data, but using robot hardware. HumanEgo, with 8 minutes of human data, beats ACT trained on 30 minutes of robot teleoperation data. The most impressive result? HumanEgo trains a single policy that generalizes zero shot across different robot arms, different cameras, and different environments, all from the same 30-minute human recording. You collect the data once at home, deploy to any lab. The awesome thing is the dataset is on Hugging Face, 122 recordings across 2 tasks. Code is on GitHub, paper on archive. If you're interested in reading further, I'll link to the project page in the description below. Also, this week, SCAIL2 is out from Tsinghua University and ZAI. And this is a character animation paper that takes a fundamentally different approach from everything else. Current character animation systems, the ones that take a driving video and transfer its motion onto a reference character, all rely on skeleton intermediates. You extract a pose skeleton from the driving video, then condition the generation on that skeleton. The problem is, skeletons are lossy. They introduce ambiguity in complex poses. They lose shape information, and when 2 people interact closely, dancing, fighting, hugging, the skeletons overlap, and the model can't figure out which limb belongs to which person. Scale 2 removes the skeleton entirely. Instead of extracting an intermediate representation, it directly concatenates the driving video's latent tokens to the generation sequence. The model gets all the visual information it needs from the raw input with no compression step. They built a dataset called Motion Pair 60K, 60,000 heterogeneous motion pairs covering single character animation, character replacement, and multi-character interactions, specifically to train this end-to-end approach. The zero-shot capabilities are the most interesting part. Because Scale 2 learns from visual context rather than skeleton semantics, it generalizes to driving sources completely outside the training distribution. One of their demos on the project page shows animal-driven animation, where an animal's movements drive a human character. Another shows egocentric video driving. Neither of these was in the training data. The multi-character comparison on their page is worth watching. In the side-by-side on close interactions, the skeleton-based methods produce tangled, misattributed limbs. Scale 2 handles identity isolation correctly. The character replacement demos show seamless background integration without the background in-painting masks other methods require. The model is on Hugging Face under ZAI. Code and dataset coming soon. If you're interested in reading further, I'll link to the project page in the description below. Also this week, Google just dropped Gemini 3.5 Live Translate, and this one is practical enough to be actually useful for a lot of people. The announcement is from June 9th. Gemini 3.5 Live Translate is live in 3 places right now: Google AI Studio for developers to build on, Google Translate for consumer use, and Google Meet for live meeting translation. The technical pitch: near real-time natural speech translation, not captioning, not transcription. You speak, and the model generates fluent spoken output in the target language as you talk. The natural part is what they're emphasizing. Prior translation systems sounded robotic and introduced long delays. Live Translate is designed to preserve the speaker's natural intonation, pacing, and conversational rhythm across the language switch. For Google Meet specifically, this means you can run a multilingual meeting without a human interpreter. One person speaks English, another hears Mandarin or Spanish or French in real time with audio that sounds like natural speech rather than a text-to-speech readout. For Google Translate, it extends the real-time conversation feature to handle longer, more continuous speech. It's accessible via the Gemini API Live API under the Gemini 3.5 Flash Model Identifier, with Translate-specific documentation available at ai.google.dev. If you're interested in reading further, I'll link to the announcement blog in the description below. And finally, Microsoft Research dropped a paper called Mirage, which introduces latent spatial memory for video world models. And the efficiency numbers here are genuinely impressive. Mirage stores scene content directly as 3D latent tokens. It never renders to RGB. The latent cache is initialized from the first frame, read for each target view, and updated with new static content as generation proceeds. Because the cache stays in latent space, there's no costly round trip through the renderer. 3 numbers from the official page: 10.57 times faster generation compared to baselines, 55 times lower 3D cache memory, world score average of 70.36, which is the highest on the benchmark. In the qualitative comparisons on the project page, Mirage is shown against 4 baselines: Spatia, Voyager, Gen 3C, and VMem across the same camera trajectory. The visual consistency of the Mirage outputs on extended sequences is noticeably stronger. Code is on GitHub, paper on archive at 2606.09828. If you're interested in reading further, I'll link to the project page in the description below. And that sums up all the highlights in AI this week. Which piece of news was your favorite? And which tool are you most looking forward to trying out? Let me know in the comments below. As always, I will be on the lookout for the top AI news and tools to share with you. Remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. Thanks for watching, and I'll see you in the next one.